this video, we're talking about multiplication of polynomials. Remember that polynomials means many numbers because poly means many and nomials means numbers. So we just have a bunch of numbers and letters here strung together with addition and subtraction signs. We might have some exponents thrown in as well. So we're going to do a couple examples where we multiply polynomials together. In this first one, we have a polynomial 4x plus 5. And a second polynomial, 3x minus 2. And because they're both in parentheses and sitting right next to each other, this tells us that we're multiplying them together. Now, more specifically, both of these are binomials because they each have two terms. And remember, bi means two. So these are binomials or polynomials that we're multiplying together. And you'll often hear when you multiply binomials together that we're going to use the FOIL method, where FOIL stands for first, outer, inner, last. So what that tells us is that we multiply our first terms together. So 4x times 3x we know is 12x squared. Then our outer terms together. So that's going to be 4x times a negative 2. 4x times a negative 2 is a negative 8x. Then our inner terms, 5 times 3x is going to be a 15x. They're both positive. And then 5 times negative 2, the last terms, which is negative 10. 5 times a negative 2 is a negative 10. Then once we've multiplied out, we're looking to combine like terms. We have negative 8x and a positive 15x. We know that that's going to give us a positive 7x. We can combine those as like terms. So the result is 12x squared plus 7x minus 10. Now you might also see an example like this where you have the quantity 5x minus 6, that's a polynomial, or more specifically, a binomial, and this quantity here is squared. Well, squaring a binomial is the same thing as saying multiply two of these together. So this is going to be equal to 5x minus 6 times 5x minus 6. This exponent just tells us two factors of 5x minus 6, multiply them together. So multiplying these together, again, our first terms, 5x times 5x gives us 25x squared. 5x times a negative 6 gives us a negative 30x. Negative 6 times 5x gives us a negative 30x. And a negative 6 times a negative 6 gives us a positive 36 because we have a negative times a negative, which is a positive. Now combining our like terms, negative 30x and negative 30x, we get 25x squared minus 60x plus 36. Now we're going to get a little more advanced here, but what I want you to keep in mind is that we can multiply together polynomials of any length, and we can multiply together any number of polynomials. So in this case, in this example, I have three polynomials, x plus 1, x plus 2, and x plus 3. They're all polynomials separated here by parentheses, but I've got three of them, so I'm not just stuck multiplying together two polynomials, but I can multiply three. And the way that we would do that is we just focus on two of them first. We're going to combine two of them and then deal with the third one. So we're going to pretend for a second that x plus 3 isn't even there. It doesn't even exist. We're just looking at x plus 1 times x plus 2, and we'll do that the same way that we did both of these first examples. So in that case, we'll get x times x, which is going to be x squared, so that's x times x. Then we have x times positive 2, so that's a plus 2x. Then we have 1 times x, which is going to give us a plus 1x. And then we have 1 times 2, or positive 2. When we combine our like terms, we'll get x squared, the 2x and the 1x combined together to give us 3x, and then we have plus 2. Now remember, this was the result of x plus 1 times x plus 2. So what we can do is put this in parentheses, and now we're going to bring back in our x plus 3. So this is when we're going to start paying attention to the x plus 3. And this is another example of, even if you aren't given three polynomials multiplied together, you might be given two polynomials where one of them has more than two terms. It's larger than a binomial. This one has three terms, which means it's a trinomial. So even if you have a trinomial times a binomial, the concept is the same. You're just multiplying every value from one polynomial by every value in the other polynomial. Let's start with x squared. We're going to multiply x squared by every value in the other polynomial. So x squared times x is going to give us x cubed. And then x squared times a positive 3 is going to give us a 3x squared. Now we're going to multiply positive 3x by every value in the other polynomial. So 3x times x gives us 3x squared. And 3x times 3 gives us 9x. Now we're going to multiply the positive 2 by every value in the other polynomial. So 2 times x gives us positive 2x, and 2 times 3 gives us a positive 6. And now we just combine our like terms across this entire polynomial we have here. We'll start with x cubed terms. There's only this one x cubed here, so we'll leave that. Now we'll look for x squared terms. We have a 3x squared plus a 3x squared. That's going to give us a 6x squared. Now we'll look for x to the first terms. We have plus 9x and plus 2x, so plus 11x. And then we have our constant term plus 6. So this is the result of the multiplication of these three binomials together. We could have also been given this problem to start with, a trinomial multiplied by a binomial, and gotten the same result. We just did this as a two-step process. So the point is, no matter how many polynomials you had, in this example we had 2 polynomials, in this example we had 2 polynomials, in this example we had 3 polynomials that we simplified to 2 polynomials before we got our final answer. And no matter the length of your polynomials, in this example we had 2 binomials, we had 2 binomials. Here we had 3 binomials, which we simplified to a trinomial multiplied by a binomial. No matter how many polynomials and no matter the length of them, the takeaway is that you have to multiply each term in each polynomial by all of the other terms in the other polynomials in order to get the correct answer.